Hi, I'm Julian.
I'm Connor.
And I'm Wilson.
And we're science students from St. John's Ravenscourt School. We've come here to talk to you today about an amazing experience we shared and how it reconnected us with a different style of learning.
Now, the three of us being high school science students, we like to think that we know boredom pretty well.
Everyone knows what it's like to stare up at the classroom clock as it doesn't seem to tick, or falling asleep before the bell rings. All students do it. The doodling, playing on your phone, poking your friend. Boredom is a part of all education systems.
And it's not our fault. It's normal. We are confined in classrooms, doing non-stimulating, tedious work day after day. What do we expect when we apply a 150-year-old format of learning to a bunch of students living in a distracting age of video games, competitive sports, and Netflix? There's going to be flaws.
However, we do believe students are eager to learn.
It's why you are all here today.
Everybody has something they like to do, a passion of sorts, be it math, science, arts. We have aspirations.
We have dreams to be the next best sports player, activist, or Nobel Prize winner.
And this brings us to our second problem with schools. We miss the big picture.
Students often find themselves wondering, how does the material they're learning relevant? How is it important, and how does it relate to the big picture?
As human beings, we naturally want to work towards an ultimate goal. However, if the incentive isn't there, we can only expect a half-hearted effort.
These obstacles all fit into the same category. Motivation. Of the students, of course. But what about the teachers? The ones standing at the front of the classroom presenting the material before us. What about the environment? How we use our learning space? We have to delve into how the information is taught, knowledge translation.
We would like to share a quote with you by TV show host and science author Stephen Johnson. And that is, if you look at history, innovation doesn't come just from giving people incentives. It comes from creating environments where their ideas can connect.
And I want you to remember that till the end of this, okay? But we're going to continue on to our journey.
Now, this journey naturally created environments where learning could be done outside of the classroom. We learned as a group that learning can be effectively achieved without the use of textbooks, classrooms, or tests.
Us three and two other students spent 2 weeks at the Experimental Lakes area of Ontario.
What we are calling ELSE, Experimental Lakes Student Experience, was an opportunity to explore what goes on at ELA and have hands-on experience working and studying with the scientists. Who here has heard of the Experimental Lakes area? Okay, very good.
For those of you who don't know, the Experimental Lakes area is a full ecosystem research facility in the Lake Winnipeg watershed. It is comprised of 58 freshwater lakes surrounded by wilderness. It is internationally renowned, and it is completely untouched by civilization, and this allows scientists to yield data from the environment rather than from a test tube in a lab.
ELA has over 50 years of data dating back, and it gives accurate information about the effects that treatments have on the lakes and its surrounding forests. It also allows them to analyze how the environment itself fixes itself and repairs itself over time.
So we had 2 weeks on site. In this time, we lived with the scientists and shadowed them as they worked and attempted to help them. The experience was incredible. It was neat to be able to sit down and have lunch with the scientist after a morning of working with them and just having normal discussions. And these talks were knowledgeable, and the ideas flowed back and forth between us.
And it's funny how, like teachers, we just assume that the scientists wouldn't want to be bothered outside their work. Have you ever seen a teacher outside of school and it's sort of weird? Well, it was sort of the same thing, but then we sort of found that these people were normal people. They were down to earth, and we talked about various topics, and it was a lot of fun.
At the same time, they acted as our teachers. They did their best to explain their master level or PhD level experiments to us at a high school level.
What surprised me was that I was genuinely interested in what I had just done, and I was eager to learn. I had an incentive, which is crucial, and it will come up again in a bit.
Also, we were constantly being tested, but this was unlike school. We weren't being examined or marked, but we still had pressure. So this is an example of some of the pressure that was on us. If you can't trust your data, what are you doing? Because all the data that we were collecting were going into the experimental lakes database.
Rather than getting a grade based on performance or attitude, the test was much simpler. We had the chance to do the scientists' jobs for them, and that is get the results for them and yield it, and then put it into their computers, where it would be added to the 40-plus years of ongoing data.
So there was always this constant pressure on, which was much different than the type of pressure we experienced in school. Let's talk about what we actually did.
So the first week, we worked alongside the scientists, collecting data and analyzing results of ongoing experiments. This ranged from going in boats out onto the lakes to going onto the on-site laboratory.
Halfway through our stay, we took a 3-day canoe trip. We set out into the wilderness that surrounds ELA and found ourselves in the environment. And you can see how beautiful it was there.
After the canoe trip, we were given the opportunity to conduct our own experiments using the ELA's equipment and their lakes.
It was a great experience, and it allowed us to apply and expand the knowledge we learned from the previous week and apply it to a subject that we were interested in. We were being put to the test. So this is us going out to collect some leeches. I decided to do my experiment on the second week about leeches because I was sort of interested in their role in the ecosystem. Lots of people just think of leeches as pests that bite you when you're swimming, but they are decomposers in the ecosystem, and they're also fish food. So they play a very important role in the lake.
Now, on the other hand, I studied zooplankton, and what zooplankton are almost microscopic little organisms that when a fish is too small to eat something like a leech, it eats zooplankton. And during the day, zooplankton hide at the very bottom of the lake, and it's very unorganized because all the fish can see them with the light. However, at night, they separate and find themselves in different depths of the lake based on the type of organism that they are, because the fish are dormant. And it's neat, because if anyone's ever seen Alien, you know how the alien's got that massive jaw that comes out? There's a zooplankton that has that, and that's what it's based off of, is a zooplankton, big-ass jaw. It's very scary, and it's just really neat to see that in real life. So, what is the significance of our experience? Well, I think we've narrowed it down to 3 points. First being, during this experience, we learned. Yes, us, up here, 3 high school students who were getting sick of school spent their summer learning. And furthermore, we enjoyed it. Going into the elk trip, I'm not going to lie, I didn't have my hopes very high. School trip over my summer break, studying science and doing homework. Let's be honest, who wants to do that? I'll let you know a little secret. My mom forced me to sign up. That's true. However, when I returned, I thanked her for forcing me to go. And that's because while we were there, we were motivated to learn, and there was never a dull classroom-like moment during the trip.
Number 2, we created an incentive. While spending time working with the scientists, they made a point of informing how important their research was and how it was being applied. An example would be Lake 226, one of the more famous lakes in ELA. And Lake 226 is responsible for testing phosphorus eutrophication. Has anyone seen this picture before?
Yeah, there we go.
Nice. Well, eutrophication is the enrichment of the ecosystem with chemical nutrients, mostly from compounds containing phosphorus and nitrogen. Now, natural eutrophication is a healthy and common process in lakes. However, eutrophication in our lakes is happening too rapidly. The high amounts of nitrogen and phosphorus found in common products like fertilizer make their way into the lakes as farm runoff. This is the cause of the exponential rates of eutrophication, which leads to dead zones and kills the ecosystem. An example of a lake that is experiencing such is Lake Winnipeg.
Now, there's debate whether it is the nitrogen or the phosphorus causing this eutrophication in the water bodies of Manitoba. The results done in a test tube lab indicate that it is indeed nitrogen. However, after doing a full ecosystem experiment at ELA, it was obvious that it was phosphorus. And this is why, and you can see on the picture here that the top, which is much greener, has phosphorus in it, while the other one, which they did add nitrogen, doesn't. And you can see that that lake is normal while the other one isn't. And this was proof, this was the real experiment that showed that phosphorus was the culprit. And this is why ELA is so important, because these results can't be replicated in a test tube, and you can't find this in a lab where the majority of experiments today are performed. Lake 226 also let us step back and see the big picture, which is something that Mike Patterson, the chief scientist at ELA, told us to try to do while we were there. While eutrophication leads to high nutrients and therefore exponential algal growth, the issue at hand isn't just a big green lake. This process is happening so much that the decomposers that decompose the algae when it dies use up all the oxygen in the lake, creating dead zones. Dead zones are places where there's no oxygen and therefore organism can't live. And when an organism can't live there, it's lifeless. And this continues to happen in the lakes until there is no more life and it is completely uninhabitable. This small issue of high nutrients leads to an entire lake's ecosystem crashing and being destroyed. Furthermore, the lifeless lake is now unable to help the forest and the area around the lake, and there is another negative impact. As you can see, the big picture is vital when looking at the environment. And we were easily able to step back and see the big picture while at ELA.
Now, the third and last point that we have is that we were able to apply our knowledge directly to the source, the big picture. The knowledge we acquired wasn't just from the experimental lakes. Some of it was from school. We used an experimental design guide that we learned about in grade 11 AP Biology. We also were using compounds in the lab that we had learned about in organic chemistry. And then when we started creating our own experiments during the second week, this allowed us to take a step further and allowed us to have no restrictions. There was still pressure. We were being tested. Our knowledge from the previous week and from all of our science classes was being tested. But we could see the difference we were making for the experimental lakes. We could see the difference we were making towards the big picture. And this motivated us to extend our knowledge and apply it.
So why is this idea worth spreading? Well, there are over 6 million students behind desks every day in Canada alone.
And that includes each of us upstage and all of you.
We depend on our teachers to get the material across. Our success is determined by how we learned. These three things determine our success.
Now, we love our teachers. They come to school every day, ambitious and ready to teach us, and they spend their extra time helping us and getting ready for their next lessons.
And when it comes to learning, sometimes you just have to sit down, bite the bullet, and learn the material. But if you get the chance, find the opportunities where you can go out into the field, into the real world.
That's where inspiration is found.
Because in the real world, we see the big picture, how what we've learned is being applied, and that's where students become passionate and motivated about their work.
We need to create an environment with these three ideas, where we apply our knowledge to the real world, we see the big picture, we create an incentive, and this sparks the motivation of students, allowing them to reach their full academic potential.
Now, not only have we created an incentive to learn, but an environment where ideas can connect.
That's our reconnection. Thank you.